Good day, everyone. I'm going to present the poster titled Recrystallization in Pearlitic Steels Processed by Severe Plastic Deformation, a Calorimetric Analysis. In this investigation, a pearlitic steel was analyzed microstructurally and thermally after undergoing severe plastic deformation, SPD, through techniques such as high-pressure torsion, HPT, and equal-channel angular pressing, ECAP. These methods introduce significant deformation, which increases the density of crystalline defects. This study explored how these deformation processes affect the steel's microstructure and mechanical properties. Differential scanning calorimetry, DSC, was used to characterize selected samples, revealing changes in thermal stability and transformation temperatures during heating. The results were compared to the steel's properties before undergoing SPD. Additionally, mechanical properties were evaluated and the microstructure was observed. The aims of this project are: evaluate the mechanical behavior of a pearlitic steel, 2.25% manganese, 5% boron, processed by HPT and ECAP. Analyze the steel recrystallization after HPT and ECAP. Analyze the thermal stability after ECAP and HPT through DSC. Moving on to the experimentation, the steel was processed through two different routes for comparison: equal-channel angular pressing, ECAP, and high-pressure torsion, HPT. In ECAP, the samples were processed at room temperature by passing them through an L-shaped channel with a 90-degree angle at an extrusion speed of 22 mm/min. The sample was rotated 90 degrees counterclockwise after each extrusion. Each passage of the sample through the die is referred to as a pass or turn, and the samples were processed for up to 7 turns. For HPT, the sample was pressed with a force of 6 gigapascals, and one of the anvils of the press was rotated 360 degrees clockwise. The samples underwent up to 6 passes. After processing by one of the two SPD techniques, selected samples were characterized using differential scanning calorimetry, DSC. Mechanical properties were estimated through micro-hardness and nano-indentation tests, and the microstructure was examined with scanning electron and optical microscopy. In the microscopy results, we observed the influence of deformation on the steel's phases. For HPT, the pearlite deformed in the same direction as the applied rotational force, and cracks appeared more frequently as the number of rotations increased. In the case of ECAP, as the number of passes increased, there was a successive subdivision of dislocation walls due to the activation of multiple slip systems, leading to a higher level of deformation. The distribution of phases changed with the constant accumulation of deformation after each ECAP pass and the direction of the process flow. DSC results show that in both ECAP and HPT, the austenitic transformation is affected by the deformation introduced in the samples, decreasing both the AC1 and the maximum transformation peak temperature as the number of passes increases. Nano-indentation results indicate that both hardness and elastic modulus increase from turn 1 to 5. However, from turn 5 to 7, a decrease is observed in both cases. This is because the actual deformation applied to the sample and its influence reach their peak after 5 turns. Further processing results in the cancellation of deformation cells and microstructural defects, in addition to the creation and growth of cracks, which also decrease the mechanical properties of the steel. In the case of ECAP, micro-hardness tests show that as the number of passes and therefore the deformation increases, the hardness also increases. However, due to the limitations of the ECAP press, tests could not be conducted beyond 5 turns. As conclusions from this research, we have to note, at turn number 5, the increase in hardness and elastic modulus, E, reaches its maximum value, and after that, the values stabilize and decrease. Processing by HPT and ECAP in steels reduces the austenitic transformation temperature by up to 12 degrees, 1.6% for HPT and 8 degrees, 1.1% for ECAP. The HPT technique produces a deformed pearlitic microstructure. This is more noticeable at the 7th turn, but cracks also appear more frequently and are more severe.